Hello boys and girls, and welcome again to another science video lesson. And in this video lesson, we will going to talk about the different layers of the Earth and as well as the special layers of it, which is the lithosphere and asthenosphere. Yes, those are the special layers, and these are very important in our quest in discovering what is the plate tectonics all about. So come join me today in this video lesson as we tackle those concepts regarding the structure of the Earth.
Science 4K.
Alright, so here we are in our lesson for this video. So the structure of the Earth and the lithosphere. So have you ever wondered how far did humanity be able to dig here on Earth? Alright, so what I mean here is the vertical. Alright, so the vertical digging process. So how far did humans achieve in terms of vertical digging? Okay, so I suggest that you can go to WatchMojo and watch their top 10 deepest holes on Earth. Okay, so with that top 10 deepest holes on Earth, you will be able to find out what are the different places in which humans did manage to dig a hole here on Earth. Alright, so it ranges from mines, it ranges from geothermal plants, and so on and then so forth. So I suggest that you watch this clip. Alright, so watch this clip from YouTube coming from WatchMojo to find out what are the top 10 deepest holes here on Earth. Alright, so let's go back to our PowerPoint. So we have right here the structure of the Earth and then the lithosphere. So no matter how far or no matter what kind of digging, alright, the humans be able to do. Okay, so humans barely scratch the Earth's surface. So what do I mean by that? So in any form of digging that was done by humans, we barely scratched the surface of the Earth. So meaning we didn't reach yet the mantle. Okay, so we haven't yet reached the mantle in the process of digging that we had for many attempts. Okay, so in digging some oil wells, in digging the Earth's crust for scientific purposes, we haven't yet reached the mantle. Alright, so that's how I think it's 40,000 kilometers. I think it's 40,000 kilometers is the only distance, or the distance that was reached by humans in terms of digging. Alright, so since we are done with digging, so before we discuss with the structure or the different layers of the Earth, let's find out first what is the history of the Earth's interior. Alright, so at first, for some 4.6 billion years ago, Earth was formed. Alright, so during that time, there are gas and other particles, okay, that is present in our primordial solar system. Okay, now because of the action of gravity, again, the very important ingredient here in the formation of the solar system is gravity. Alright, so that is gravity. So with the action of gravity and conservation of angular momentum, so the gas particles and other dust particles that are present in a primordial solar system that we have 4.6 billion years ago has it starts to form. Alright, it starts to form, and because of gravity, it pulled together those particles, dust, and other stuffs, and formed the, as we all know, the star in our solar system, the sun. Alright, so because of this gravitational pull, it formed the star, which is called the sun, and became the center of our solar system. Now, with the action of the gravitational pull of the sun, some dust particles formed the inner planets like the Mercury, Venus, Earth, and Mars, and some particles that resist, or some particles that are blown away from the center became the gaseous giant. So we have the Jupiter, Saturn, Uranus, Neptune, or even Pluto, something like that. Alright, so that was 4.6 billion years ago. 1 billion years after the formation of the Earth, there is a planet-sized object that smashed or bombarded the Earth, and it rendered the Earth fragmented. All right. Now, because of this bombardment by a planet-sized object, it is the precursor of the formation of the moon. Okay, so the moon that we know during nighttime, that was formed when the Earth was bombarded by a planet-sized object, right? So planetary collision, something like that. So imagine you will have a planet colliding with another planet. So I don't know what kind of devastation it will create on a certain planet. So it left the planet liquefied, right? So it left the planet liquefied, and over billions of years, the planet's surface is in a form of molten lava. Until such time that particular lava, that molten lava that was product of the bombardment of a planet-sized object, later cooled down and formed the igneous rock. And these igneous rocks are the ground that we are stepping right now, the surface of the Earth that we are stepping right now. Okay, so it happened a billion years ago. All right. So now, as of now, the second heating of the Earth comes from the core. All right. So what is inside its core? It contains a lot of radioactive isotopes like uranium, thorium. Okay, so something like that, plutonium. Okay, and this particular radioactive isotopes enables the Earth's core to continue to heat up. Okay, so as it decays, the nuclear decay provides the heat necessary for the core to function. Okay, and as we speak now, this particular radioactive isotopes begins to heat up the Earth and continually heats up the Earth, and that is the reason why the Earth's core is molten. And as the time goes by, the crust cools down and it becomes hardened. All right, so that's the reason why we cannot feel the heat of the Earth's core in the crust because of thermal gradient. Okay, so that's the early history of the Earth and its formation. Now, because of this history, it formed the different structures of the Earth. So the Earth has different structure thanks to the seismic waves that we have learned last time. So the three layers that we have here are the following. So we have core, mantle, and crust. Okay? So as we go over with this particular topic, we will try to find out what are the things found in these layers that we have right here. Okay? So what are these continental crust? What are these oceanic crust? What are these outer core and solid metal inner core? All right. Now, what can we find, or what are the elements that we can find here on Earth? Okay. So majority of the elements, number one is iron, that is 35%, which is mostly found in the Earth's core. All right. So we have oxygen. Oxygen is the primary composition of the Earth's crust, followed by magnesium. We have the silicon, and then so on and so forth. All right. So categorically speaking, the crust has the following elements. So we have oxygen, silicon, and aluminum. The mantle has various forms of silicates, olivine, and pyroxenes. And for the core, we have iron, nickel. Okay, majority of the structure of the core is made up of iron and nickel. So minority minority of those elements like oxygen, silicon, and sulfur are found in the core in small amounts. Alright, so what does the olivine look like? So it looks like this one that you have right here. So this is a silicate. So what do you mean by a silicate? Silicate is a structure made up of silicon and oxygen. This is a chemical structure made up of silicon and oxygen, and it differentiates depending on the heat and pressure present in the Earth's interior. Okay, so these are the pyroxenes. As you can see, it contains different structure or color compared to your olivine that we have earlier, right? So this is the olivine. All right, so that is the composition of the Earth. So don't forget, the core is made up of iron and nickel. All right, so how do we know what the Earth is made of? All right, so in the previous discussion that we have, we tried to find out, we tried to locate the epicenter of the earthquake using seismic waves, and it is the same technique. It is the same technique, the seismic waves, that we use to find out what is inside the Earth. Alright, aside from the acquisition of satellites, land, sea, and air monitoring, fieldwork, mines, and something like that, with the use of seismic waves, we be able to find out how many layers does the Earth have, and what are the characteristics of this layer. Alright, so we have the P waves. So the reason why there are P waves is because the waves, like the P waves that you have right here, are being refracted to the core. Alright, that are being refracted on the core. So what does it mean? It means that the core has different composition. Okay, the moment that the P wave is being refracted, it means that there is something inside the Earth that has at the center of the Earth that is said to be slowing down the P wave. Okay, so it creates the infamous P wave shadow zone that you have right here. So that is from 103 degrees up to 142 degrees, okay, of angle. All right, so that is the P wave shadow zone. So what did we get? All right, so what did we get upon studying the P wave shadow zone? We got, okay, so we have an idea that the core is made up of something like a liquid. Okay, so it is made up of something like a liquid, and certainly speaking, the Earth is made up of a central core. Okay, there is something at the center of the Earth, so because of the P wave shadow zone. Alright, so the next one that we have right here is the S wave shadow zone. As you can see here, at 103 degrees of angle on both sides, it creates your S wave shadow zone. So what is the reason behind the formation of the S wave shadow zone? So S waves, as we recall, S wave cannot pass through liquid. So there's one thing that we gained upon studying the S wave. Okay, upon the presence of the S wave shadow zone, we have an idea that the core is liquid. Okay, so the core is liquid, and because of the S wave cannot pass through it. Okay, so the core is liquid. So and aside from that, the core of the Earth is massive. Okay, now upon forming your S wave shadow zone, we found out that the core of the Earth is massive and it is made up of liquid. Okay, so those are the things that we gathered. Okay, those are the things that we have gathered, or the ideas that we have gathered by studying the behavior of the seismic waves. Okay, so basically speaking, seismic waves are important in studying the layers of the Earth. Besides, no one can get inside the Earth, so no human process still can get inside the Earth. Okay, so these are the different layers of the Earth that we have, and the first thing that we were going to discuss here is the Earth's core. Alright, so we have here the Earth's core. So upon studying the seismic waves, we found out that the Earth has a core. Alright, not only that, okay, now because of because of seismic waves, we be able to divide the Earth's core into two, okay, accordingly. So because of the formation of the S wave shadow zone, okay, because of the behavior of the S wave, it cannot transmit Okay, it cannot pass through a liquid matter or liquid medium. All right, we have an idea that the outer core is liquid. Now, the fact that the P wave, after passing through the liquid outer core, it slows down and then goes back again to its original speed. It tells us that the inner core is somehow solid. Alright, because of the behavior of the P waves. Okay, so the inner core affects the velocity of the P waves as it travels through that certain area. So we got an idea that the inner core is somehow made up of solid material. Alright, so now both of the core that we have right here, the outer core and then the inner core, is very important in generating the Earth's magnetic field. Okay, it is very important in generating the Earth's magnetic field. Now, without the Earth's magnetic field, this planet, the planet Earth, will render uninhabitable. Alright, so life here on Earth will not be possible without the Earth's magnetic field, because the Earth's magnetic field is the one that maintains its atmosphere. Okay, it is the one that protects us from dangerous solar particles, okay, coming from the sun. So that's how important the magnetic field of the Earth is. Okay, so if you are wondering what will happen if the Earth's magnetic field suddenly disappear, so you don't need to look somewhere else. So just look at the planet Mars. The planet Mars, there is a hypothesis that the planet Mars once looked like an Earth. Because of the disappearance of its magnetic field, its atmosphere suddenly disappeared. Okay, and it rendered the planet lifeless. Okay, so because of the disappearance of that very important magnetic field. Alright, so in the core, the boundary between inner core and outer core respectively is known as Lyman's discontinuity. Okay, so it is known as Lyman's discontinuity. That is the boundary between inner core and the outer core. Alright, so probably the core is made up of nickel and iron. Okay, both core, so outer core and inner core. The outer core is made up of liquid nickel and iron, while the inner core is made up of nickel and iron in a solid form. Okay, some traces of sulfur and nitrogen are present, and also some radioactive elements like uranium, thorium, we have plutonium, something like that. Alright, so those are the things present in the core. Alright, and these radioactive elements is also very important. It keeps the Earth's core continues to supply heat. Alright, so that's the thing that you should take note of regarding the Earth's core. Okay, so there's a meme here. What is the inner core made of? Ayan. Alright, so that is nickel. Okay, so that is nickel, not knicker. Okay, so now just to give you an idea how what is the pressure at the inner core. Okay, so at the core itself, so the pressure in the core reaches around 3.5 million atmosphere. Okay, so it reaches around 3.5 million atmosphere. So comparing it to the atmosphere, or comparing it to the pressure on the Earth's surface, that is 1 atmosphere, that is several times, so 500% increase in pressure when you go to the inner core itself. Okay, so that's the pressure that you will experience when you go to the inner core. Meanwhile, we have the temperature, not only the pressure, which is very dangerous, but also the temperature. Alright, so the temperature is around 6,000 degrees Celsius or 11,000 degrees Fahrenheit. So this heat that you have right here on this core is very important in generating the next topic that we have, which is called the plate tectonics. Alright, so this heat is very important in generating this plate tectonics process that we have, okay, for the next topic. Okay, so the question that I will ask you here, okay, the question that I will going to ask you is how come that we cannot feel the heat coming from the Earth's core in the Earth's surface? Alright, so again, the question is how is it possible that we cannot feel the 6,000 degrees Celsius, 6,000 degrees Celsius of heat coming from the Earth's core on the Earth's surface? Okay, so how is that one possible? Okay, so just leave your answer in the comment section of this video. All right, so it will help me a lot in the algorithm of this video in YouTube. All right, so if there is a Lyman's discontinuity, all right, that surrounds your outer core and inner core, there is also a boundary between mantle and core. So we called it Gutenberg discontinuity. Okay, so we called it Gutenberg discontinuity. So what is this boundary all about? So this boundary keeps the material from the core. It keeps the material from the core not reaching to the mantle, and the material from the mantle not reaching to the core, vice versa. All right, so that's how important this core mantle boundary here. And also in this boundary, it is only the heat that is being transferred from one layer to another. All right, it is only heat that is being transferred. All right, so as I've said earlier, that the heavier portion of the mantle cannot reach the core, and the lighter portion of the core cannot reach to the mantle. Okay, only the heat. Okay, that is the core mantle boundary. Up next is the mantle that we have on this next layer. Okay, all right, so we go now to the next layer. So that was the core, and in this layer that we have right here, this is one of the largest layer of the Earth. All right, even larger than the core itself. Okay, so one of the largest layer of the Earth is called the mantle. Okay, so the mantle, and the mantle is the middle part of the Earth's interior. Okay, it is the middle part of the Earth's interior. So as you can see on the picture that you have right here, you have a lot of weird things. Okay, you have a lot of weird things happening on the mantle. There is your subduction zone, there are volcanoes, there are earthquakes, there are ridges that you have right here. And this stuff that you have right here are very essential in the formation of your lithospheric plates. Okay, so the stuffs that you have, or that is happening, the stuffs that you are that is happening on the mantle that you have right here is very important in the process in the formation of tectonic plates. Okay, so aside from that, the mantle is somehow 2,000 kilometers, or 3,000, more or less 3,000 kilometers thick between the crust and the core. So that's how thick it is, okay, compared to the crust, or even compared to the core. Alright, now as you can see here, the mantle also, there are parts of the mantle that varies in terms of density and depth. Okay, so previously we happened to learn that as the depth increases, as the depth of the layer increases, so as you can see here, from 400 to 700 kilometer, the velocity of the seismic waves also increases. So they are directly proportional to each other. Okay, now not only that, the density as well. So as the density of the material varies in different layers of the Earth, the wave velocity also increases. So it means that the density is somehow directly proportional to the wave velocity, or the seismic waves velocity. Okay, and it is very consistent. Alright, so this is very consistent on all portions of the mantle, whether it is the part of the upper mantle and the lower mantle. Okay, so and aside from that, density and wave velocity also is affected by the temperature, the increase in temperature and increase in pressure inside this layer that we have right here. Okay, so that is the relationship between density and the seismic waves velocity, and also with the depth and the seismic wave velocity. Alright, so in different layers, or in different distances on your mantle, we can find several materials or minerals in a form of olivines, like the one that you have over here. Alright? So this formation of silicate materials like the one that you have right here is affected by heat and pressure. Okay? It is affected by heat and pressure. Now, without heat and pressure, this particular formation of silicates that you have right here, this one, okay, over here, is somehow impossible. Okay? So, starting with 400 kilometers, the formations of this kind of silicates are found in that particular layer. So, we have here the olivine, the topaz, zoisite. Alright? Okay? And these are the materials or these are the minerals that are found at 400 kilometer portion of the mantle. So, as the heat and pressure increases, the structure of silicates also changes. Okay? Now, the structure somehow collapsed and it became now different. Okay? Like the one that you have right here, the emerald and aquamarine, and the chain form of silicates, which is the asbestos and jadeite. Alright? So, that is at 400 kilometer. Alright? Now, below 400 kilometer or above 400 kilometer, that is 700 kilometer on the mantle, you can see that the structure of the silicate became more complex. Okay, so the structure of the silicate became more and more complex. Okay, that is the reason why the existence of amethyst, quartz, talc, and biotite on the 700 kilometer mark layer of the mantle is somehow very noticeable. Alright, so these structures that you have right here is found at 700 kilometer portion of the mantle. So these are the minerals that are found, okay, at different layers of your mantle. Okay. Okay, so please take note that the mantle is made up of two portions. So we have the upper mantle and the lower mantle. So because of the consistency, alright, so because of the characteristics of the lower mantle, okay, there are no earthquakes that is happening on the lower mantle. In the upper mantle, because that is where the seismic waves passes through, okay, there are a lot of earthquakes that is recorded in the upper mantle. Lower than, there are a lot of earthquakes happening in the upper mantle than in the lower mantle. So, always take note of that one. Okay, so the next thing that we will going to discuss here after the mantle is the crust. Alright, so the crust. Okay, so this is the part of the planet. Okay, this is the part of the planet where we live. Okay, where the buildings stand. Okay, where the oceans are located. Okay, so this is where our house is standing right now. This is where we stand, the crust. Okay, and there are two portions of the crust. Okay, now these two portions are not similar to each other. They have their own unique characteristic. So the first portion that we have right here is the continental crust, and the other portion of the crust is called the oceanic crust. Okay, so it is very it is a self-explanatory. It is self-explanatory why oceanic crust is called oceanic crust. Okay, so most of the oceanic crust are found underneath the water. Okay, so now let's take a look at the characteristics of each of the kind of crust. So the first one is the continental crust. Continental crust are thick, all right, in terms of thickness, all right, and they are buoyant. Okay, so what do you mean by buoyant? So buoyant are, in other words, less dense. Okay, so less dense meaning to say that when you put the continental crust on something that is denser, it will float. Okay, so the continental crust will float. All right, next one, we have the continental crust in terms of the continental crust in terms of age. It is mostly old. All right, it is mostly old. Okay, in terms of age. Meanwhile, the oceanic crust is somehow thin and dense. Okay, so that's the opposite, exact opposite of the continental crust. And when we said dense, it sinks. Okay, It doesn't float, it sinks. And in terms of age, oceanic crust is younger than the continental crust. Okay, so let me know in the comment section below, why do you think that the oceanic crust is younger than the continental crust? What could be the reason behind this one? Alright, so the crust itself is the thin layer, alright, the thin, solid, brittle material that covers the earth. Okay, although it is around 40 kilometers, alright, more or less 40 plus kilometers, still the crust is a thin layer of solid brittle material that covers the earth. Okay, so it is somehow not as thick as the mantle or even the core. So crust is subjected to a lot of changes. Alright, so there are some differences in the crust depending on what surface you are on. Okay, so as I've said earlier, there are two kinds of them. So we have the continental crust and then the oceanic crust. Okay, so now in terms of the movement of in terms of the velocity of the seismic wave travel faster in oceanic crust. Okay, so why do you think so? It's because oceanic crust is somehow denser. The material that makes up your oceanic crust is somehow compact. It allows the seismic wave to travel much faster compared to the continental crust. Okay, so that's a good thing to take note of. Okay, now the continental crust is made up of granite and oceanic crust is made up of basalt. Now if you haven't seen yet a basalt is somehow a grayish black rock that makes up most of the oceanic crust. Okay, so these are product of volcanic eruption underwater, and in terms of definite composition, the material that makes up your continental crust is called sial. Okay, so the material that makes up the continental crust is called sial, and sial means silicon and aluminum. Right, so the one that you have right here, silicon and aluminum. Okay, meanwhile, since the oceanic crust is made up of basalt, it is made up of elements. Okay, it contains elements like sima. Alright, so this is called sima. So silicon and magnesium. So sima. Alright, so oceanic crust is made up of sima and continental crust is made up of sial. Alright, so that's the difference between oceanic crust and the continental crust. Okay, now before you go to the crust, there is a boundary that separates. There's a boundary that separates the mantle and the crust. We called it the Mohorovicic discontinuity. So what is Mohorovicic discontinuity? This is the part where the seismic waves changes its velocity upon entering another layer. For example, if the seismic wave comes from the crust, as it enters the Mohorovicic discontinuity, it suddenly increases its velocity prior to enter to the mantle. Okay? So we called it Mohorovicic discontinuity, or in short, MOHO. Alright. So again, this is the boundary between, just like the Gutenberg and then the Lyman's discontinuity, Mohorovicic discontinuity is the boundary between crust and the mantle. Okay? Now, the continental crust is less dense because it is made up of granite type of rock, and oceanic crust is made up of basaltic type of rock. Okay? So, basaltic rock has more iron compared to the granite type of rock. Okay? So, just to demonstrate the differences between the oceanic and continental crust, I have right here a PET simulation. So this simulation that I'm using right now is courtesy of PHET simulation. So I will put the website link below for you to visit their website and try to discover all the simulations that they have on different disciplines of this different disciplines of science, and also they have also simulation format. All right, so as you can see here, we have here the oceanic crust and continental crust. Okay, so in terms of composition, the more iron it is, the more denser the crust gets. Okay? Even though the thickness is somehow very thin, the one that you have over here. Okay? So even though the crust or that particular part of the crust is very thin, still the density, because of its composition, that the one that you have right here, because of its composition, okay, the density doesn't change. Okay? So the density doesn't change. Now, when we talk about the continental crust, so the continental crust is made up of a lot of silicon that makes it less dense, and since it is less dense, it is much thicker compared to your oceanic crust. So what does it mean? Okay, so if you happen to notice the thickness, if I vary the thickness of the continental crust, the density doesn't change. Alright? It's because of its composition. Okay? It depends on its composition. So the density doesn't affect, or it is not affected by the varying thickness of the continental crust. Okay? So it depends mostly on the composition itself. Alright? So this is the difference between continental crust and oceanic crust, respectively. Okay, so let's go back to our okay, so there are special layers of the Earth. So in the introduction of this video, I've said that there are special layers of the Earth. So in the mantle and crust, okay, there are layers which is very essential in the study of plate tectonics. We have here the lithosphere and the asthenosphere. Okay, so we will try to find out what is lithosphere first. So what is lithosphere? Lithosphere is a solid brittle rock that is present above the asthenosphere. Okay, it is just a place, all right? It is made up of solid brittle rock that are found in the that is found above the asthenosphere. So if we will going to magnify this one, so the lithosphere is made up of two things. Okay, so we have, okay, you are correct, that is the upper mantle, and also we have the crust. Okay, so basically speaking, lithosphere is made up of the upper mantle, some parts of the upper mantle, and the crust. Okay, now the lithosphere is very essential in our next lesson that we will have, because lithosphere comprises, or lithosphere makes up your tectonic plates. All tectonic plates here on Earth are made up of lithosphere. Okay? So, aside from that, lithosphere is made up of, includes, alright? So, the lithosphere includes mojo, and as I've said earlier, some parts of the upper mantle. Alright. Now, in contrast, we have the asthenosphere. Asthenosphere doesn't have any part of the crust. It doesn't contain any parts of the crust. It is purely made up of upper mantle. Okay? So if we will going to magnify it right here, as you can see here, this one over here, the asthenosphere is made up mostly of the lower portion of the upper mantle. Okay? The lower portion of the upper mantle. Now, it has a weird characteristic. Okay? It has a weird characteristic. So, why is it that the seismic waves suddenly decrease as it reaches the asthenosphere? It's because of its consistency. It is because of its consistency. It is made up of semi-fluid. So as you can see, or as you recall, the seismic waves, or especially the P wave, it slows down when it encounters a liquid substances or liquid object. Okay, so if it encounters a liquid object, so the seismic waves slows down. So that's the reason why the asthenosphere is made up of semi-fluid material. Alright, so it is made up of elastic semi-fluid material, just like the plastic balloon that you have right here, the material. So this thing that we have right here that is used in plastic balloon, it has a similar consistency with the asthenosphere. Alright, so that is the plastic balloon. So these are the two special layers of the Earth. We have the lithosphere and asthenosphere. Alright, so just to bring them all up in one picture, so the lithosphere is made up of parts of the upper mantle and the crust, okay, including the continental and then the oceanic crust in the lithosphere. Meanwhile, the asthenosphere is made up of the lower portion of the upper mantle. Okay, it is made up of the lower portion of the upper mantle that you have over here, and both the lithosphere and then the asthenosphere are part of the upper mantle. Okay, so they are both part of the upper mantle. Alright, so the lithosphere is broken into plates because if the lithosphere is sitting on an unstable ground, okay, if the lithosphere is sitting on an unstable asthenosphere, the tendency it will likely to move from one place to another, just like giant ice sheets floating on the water. Alright, so that's how lithosphere is being portrayed here. Okay, just like the ice. Okay, so that's the lithosphere, and it is analogous to an ice floating on water. So because it has this kind of analogy, okay, that makes this particular formation that you have right here makes up the foundation of plate tectonics. Okay, so the plate tectonics explain why there are changes in the Earth's surface. Okay, these changes are brought about by earthquakes, volcanoes, and mountain buildings. Okay, these are all possible because of the configuration of the lithosphere and the asthenosphere in the Earth's layer. Okay, in the Earth structure. Okay, now as you can see here, even though this is a meme, okay, so as you can see here, the person who is standing above the rubber balloon cannot maintain stability. Okay, the person cannot maintain the stability that he wants because the balloon itself is unstable. Alright, the balloon itself is unstable, so that is the reason why the person above moves from one place to another. Okay, and that's the effect. Okay, that's the effect of having an unstable asthenosphere. Okay, now because of this phenomenon, okay, it allows the Earth to have earthquakes, volcanoes, and mountain buildings. Okay, so that is plate tectonics. And okay, now volcanic eruption creates something on the Earth's surface. Some of them destroys the Earth's surface, and the movement of the lithosphere creates mountains. Okay, in some places. Okay, now in the next topic in the next video that we will have, we will going to talk about these plates, these lithospheric plates that we have right here. As you can see, we have here major plates. So major plates are said to be the largest plates that you have over here. So we have the Pacific plate, for example. We have the North American plate. We have the South American plate, the African plate, as some examples of major plates. So we have here the minor plates that we have. We have here the minor plates. So we have the Juan de Fuca plate, the Cocos plate, the Scotia plate, to name some. Okay, so these are the plate tectonics, or these are the tectonic plates that divides the Earth respectively. And upon the movement of these plates that you have right here, upon the movement of the plates that we have right here, it creates the continents that we have known right now. Okay, so we have the Africa, the South America, then the North America, the Europe, so on and so forth. Okay, because of the movements of these plates that you have right here. Alright, so this will be a topic for another video, so you may want to subscribe on this video for you to be notified as I release this video that we have, that will talk about this tectonic plates that you have over here. Alright, so with that, today we have learned the following things. One are the layers of the earth. So what are the layers of the earth? So we have the core, we have the mantle, and we have the crust. Okay, so the core is made up of two portions. So we have the outer core and the inner core. So we have the outer and the inner core. Now, how did we discover that there is an outer core and inner core? That is seismic waves, right? Because of seismic waves. Now, the mantle is made up of two portions. We have the upper mantle and then the lower mantle. So the crust is made up of two things. So we have the continental crust. All right, there are two kinds of crust. So we have the continental crust and the oceanic crust. Okay, so we have the crust itself. Okay, we have the lithosphere. So the lithosphere, as we recall, one more time, the lithosphere is made up of crust and upper mantle. Okay, so don't forget that one. Okay, and the asthenosphere. Asthenosphere is made up of portions of the upper mantle, and asthenosphere is semi-fluid, and that's the reason why we have the foundation for the plate tectonics. Okay, so there are major plates, there are minor plates that makes up this planet that we have right here. Okay, and the movement of these plates, because the movement of these plates that we have creates an ever-changing Earth surface. Now, if you have learned all these things that we have right here, okay, if you happen to learn all these things that we have right here, then therefore, great success. All right, so okay, so I think you did achieve. Okay, I think you did achieve great success. Okay, so that is the Earth structure. Okay, that is the Earth structure and the lithosphere. Okay, in this particular video lesson. Okay, so now as I end up this particular video, so if you happen to learn, or if you get something, or if you did get some value from this video lesson, just hit the like button, and okay, by all means subscribe and hit the notification bell for you to be updated with more science videos like this in the future. Now, if you do have suggestions of any science topic that you want me to create in the future, just put it in the comment section of this video. It will help me a lot in the algorithm for this YouTube channel that I have right here. Alright, so let's see each other next time on the next science video lesson, and happy learning everyone. Okay, goodbye guys.